All right, guys, here we go. Happy snow day. We're just going to roll through, and if I make mistakes, we're just going to keep going. So today's lesson is gravitational force number 1. Learning target is going to be to explore gravity as a force and as a gravitational field. All right, you'll know you're successful today by if you can calculate the force of gravity and G. Describe how changes in mass and radius affect force of gravity and G, and distinguish between force of gravity, and our gravitational constant, which is big G, right there. Boom. All right, so let's get started. So what is a gravitational force? What is a grav force? Big question mark there. All right. So we will say this is the attractive force between two objects with mass. And this is one of our 4 fundamental forces. Fundamental forces. Boom. Okay, so cool. We can draw a picture of this situation. We have 2 objects, M1 and M2. There is, and a radius between them of R, let's say. There's a gravitational force between them. Grav force. Cool. That pulls them together. Heck yeah, awesome. All right, and this distance is the distance between the center of masses. So not edge to edge, but the center of mass 1 and the center of mass 2. That's where the radius is that we're talking about. Cool. So we have Newton's universal law of gravity. Right? And this is our big equation that we've been talking about for a long time. Force of gravity equals, but normally we say mg, all right, but this time we are going to say something different. G m1 m2 over r squared. All right, this is the universal law of gravity for anywhere in the galaxy. Sweetness. All right, next part, this weird G thingy, what the heck is that? All right, let's talk about that up here. G is the gravitational constant. Right, and this constant is the constant of gravity everywhere in the universe, which kind of evens everything out, whether you're on Earth or Jupiter or some faraway distant place. Right, and this was measured by a guy named Henry Cavendish. He measured this gravitational constant in the metric system for the first time. And so, without further ado, G equals 6.67 times 10 to the negative 11 Newton meter squared over kilograms squared. Yeah, that's a weird unit. That's pretty fun, right? This is the more important part. 6.67 times 10 to the negative 11. That is our gravitational constant. Boom. Let's do a quick example problem. Alrighty, example. We have two people. Let's say this is Mr. Little, Mr. L. And who do we want to say today? We'll say that I am talking with Shane. Hi, Shane. And in the center of our heads are 5 meters apart, right? And so Mr. Little's head is 7 kilograms, and Shane's head is 8 kilograms, because he's pretty dang smart. He's smarter than me, that's for dang sure. Right? Getting extra sleep every morning. So they are separated by 5 meters, as we said. So what is the force of attraction? Force of attract. In other words, what is force of gravity between them, or the force of attraction between me and Shane? All right, so force of gravity equals G m1 m2 over r squared. Plugging in some numbers, we get 6.67 times 10 to the negative 11 times 8 kilograms times 7 kilograms. Those are the masses of our heads, divided by the distance between us, which is 5 meters squared. Right? Doing a little mathy poo, you get 1.49 times 10 to the negative 10th newtons. Yeah, there's not very much force there. That would also be known as force of gravity equals 0.000000123456789 149 newtons. Yeah, love you, Shane, but it's not that much. Keeping on rolling, we're about halfway there. Glad you're still with me. Gravitational field. Gravitational field. Okay, a G field describes the effect that a mass has on the space around it, and how that space would cause a force on a second object placed in that field. You can see that description on the notes that I've included. I'm not going to spend time writing it out right here. The qualitative idea of this is that, like, imagine we're on Earth. Every spot, no matter where you are around Earth, you're going to get pulled towards Earth as such, right? But the idea here is that the closer you are, the greater the force that you're pulled at, and the farther you are, the less force there there is, right? And so we're going to talk about this right here. So this is a gravitational field around Earth, the grav field. Nice, we're at the 10-minute mark. We're almost there, almost finished. So the so the equation we have for this, force of gravity equals G or mg. That's our normal thing that we say. And now we could put our new equation into that situation. And now our mass is our mass of the Earth and the little mass, the same mass, whatever person or satellite or object, alien, you know, this is whatever mass they are. This is the mass of the Earth over our radius squared. Right, that's what the equation we had before. The thing that cancels is the m's. So our G field is equal to G m of the main source of gravity over r squared. That is your gravitational force. Sorry, gravitational field. Last but not least, the quantitative version. For Earth, calculate the G field. For Earth, calculate G. We know that this should be about 9.8 meters per second squared. So that's what we're going to shoot for during this little example. We're almost there. This is going to be great. All right, just so you guys have a little more information for this problem, the radius of Earth equals 6.4 times 10 to the 6th meters. All right, that's going to be a common one that you're going to need to know. And the mass of Earth equals 6 times 10 to the 24 kilograms. That's also one you're going to need to know, but it will be included on the equation sheets. So G equals G m Earth over r squared. So it's 6.67 times 10 to the negative 11. Mass of Earth, 6 times 10 to the 24th over 6.4 times 10 to the 6th. Oh yeah, it's going to be a hard lesson in, oh crap, we forgot to square. Square this bad boy. Hard lesson in exponents. We'll talk about that when we have next class. All right. So doing a little mathy poo, you should come out to getting that G equals 9.8 newtons per kilogram, also known as 9.8 meters per second squared. You made it through. Congratulations.